virtually any building needs ventilation air and outside air for better indoor air quality. The main reasons we got into the IFL project have to do with things like the increasing importance of LEED certification, ASHRAE's new standard 62 for higher ventilation rates, and conversations really with building owners and developers through various organizations, and the problems that they have run into with poor indoor air quality. Applied Air has always been an expert at 100% outside air. All of our traditional product lines have been essentially 100% outside air units. So we realized that we have a core expertise that helps to solve the problem. Building on that core expertise and evaluating what the market really said they needed in terms of some additional things like dehumidification, better temperature control in terms of finer control systems, the ability to either produce neutral air or cool air. All of those factors came together as we developed our specification for the product. We decided we would start from a clean slate, building upon our known expertise of 100% outside air, but now incorporating all of those features and requirements that we've gained from owners, consulting engineers, and studying the various codes and standards. And that's really where the IFL came from. In talking to owners in particular, particularly about the cost of building a parapet around a rooftop mounted piece of equipment. The cost of that parapet is amazingly high. So one of the things in the IFL is we deliberately made that unit as low profile as possible. The IFL was designed to be modular. We also took the tack that all panels will be the same size, whether it's the core part of the unit or some accessory. The panels will all be the same. All the doors will be the same. All the frame rails will be the same. So even though it looks like there's a lot of different components, there's really not. There's a lot of common elements. That allows us to do a lot of pre-manufacturing of panels because we know they'll always fit because they're always the same size no matter what the module is. As I go to meetings with building owners and listen to their concerns about things like not only just the quality of their building, but probably more importantly, the cost of their insurance. The mold issue has driven their insurance costs through the roof. So anything that they can do to control the mold issue, humidity issues, is very important to them. And that's one of the reasons why the IFL is designed the way it is.
Let's hear from consulting engineer and MESTEC board member, Bill Coad.
The biggest problem that we have in this industry is humidity control. Somewhere along the line between when Dr. Carrier defined what air conditioning was, somewhere back in the 20s, and today, we forgot about dehumidification. The use of the dedicated outdoor air unit really does solve a lot of problems. Cooling, dehumidifying, filtering outdoor air is a much different problem than doing cooling and heating recirculated air. It has different kind of contaminants in it. The biggest problem with the outdoor air in any kind of a humid climate is it has a lot of moisture in it. Virtually all the humidity problems we have in buildings, the moisture came from the outdoors. Okay, so now if we have a unit that's dedicated to drying the air before it puts it in the building, we never have to worry about it again. Let's go through the unit the way a consulting engineer would look at it. I really think that the casing should be made with a double wall with insulation between it. Anything downstream of the cooling coil where condensation is likely to occur shouldn't have materials that absorb moisture. You come from the outside into the unit through some storm-proof louvers so you don't pull in snow and rain. Then we have a damper, and this is a two-position damper. It's not a control damper. It's either open or closed. But when it closes, we want it to be 100% closed. So we put in a 100% shut-off damper. Before the preheat coil, we usually put the filters. Now, the filter is a very, very important part of the unit because we're trying to filter the bad stuff from the outside to keep it from coming in. It could be chemicals in an industrial location like this. It could be particulate. We can filter out solvents and chemicals with chemical filters. So you can, and again, we're only buying a unit for ventilation air so we can afford to put in the right kind of filtration. After the damper, we need a heating coil in a temperate climate, anywhere up north, the Midwest, the Northeast. Now, remember, as we're talking about this unit is not a big unit compared to a recirculating unit. If the recirculating unit is 100% of the air that's circulated, this unit is only 20%. So we can afford to put the best preheat coil you can think of in there because it's a small coil. Downstream of the heating coil, we normally have the cooling coil. The cooling coil is a special coil. Now, it's designed differently than most of the cooling coils you'll see because most cooling coils are designed for recirculated streams. When we put a cooling coil in a dedicated outdoor air unit, we want to have the fins pretty far apart, okay, like 1/8 of an inch. Any cooling coil in any air handling unit should be installed in such a way that you can clean it. You should be able to get on one face or the other with cleaning apparatus and clean the dirt out of the coil, either from the leaving face or from the entering face. So you have to be able to get to both sides, but only to be able to have enough room to clean from one. But you want to get to the other one to use a light or something so you can look through and see if it's foul. With the service that you get and the condensation you'll have, particularly a humid climate, with the dedicated outdoor air unit, it should have a drain pan that's sloped in two directions to a drain, so that the water actually flows to a point. Okay, downstream of the cooling coil, all we have is the fan, and then that fan will get the air wherever you want to put it, either directly into the spaces or into the entering side of a recirculating air handling unit, so it's been all cleaned and thermally conditioned.
If you were to configure an IFL totally, you have the ability to put 2-inch filters in the intake hood, 2-inch pre-filters in the filter box, 12-inch high-efficiency filters in the filter box, and then an additional 2-inch filter bank in front of the coil. You have 4 levels of filtration in an IFL. That does 2 things. One, you're going to get clean air. The second thing it does, though, is it does tend to drive up your static pressure. The IFL comes standard with a plenum fan and certified at up to 5.8 inches of total static pressure. So we have a unit that at its very essence has the ability to handle 4 levels of filtration, an 8-row coil, a 2-row reheat coil, plus a very high efficiency gas-fired burner. We were looking for this very high turndown opportunity. If you were to just go by the standards, you could set your unit up for high fire, you could set your unit up for low fire, and as long as you're clean at those 2 points, they allow you to claim that as your turndown. We're not comfortable with that. We want, from high to low, clean the entire range. That's how we define turndown, is if you can burn clean through that entire range, that's your real turndown. So one of the things in our new burner development project is to achieve very, very high turndowns, completely clean through the entire range.
I think a person putting in any kind of an air handling unit today, almost any kind of a piece of machinery in a building system, would be foolish not to use DDC. If nothing else, it gives you information. For years and years and years, I prided myself on the fact that I knew what was happening. Now everybody knows what's happening.
Applied Air is going full bore with DDC controls. The IFL will come standard with direct digital control system. Not only is the direct digital control system programmed to control the function of the unit itself, but it's also monitoring conditions, collecting trend information, collecting alarm conditions, and providing access to all that information either through a BACnet connection locally or even over the internet. If you have internet access through a PC, a cell phone, a PDA, with the DDC control system in the IFL, you can actually look at your unit, see if there are alarm conditions, look at trend analysis, reset temperatures. All of that is available to you through the internet. So it's a tremendously powerful tool beyond simply controlling the unit itself. We also have built into the system the 4 most commonly used communication protocols in the digital control world. Standard protocol is BACnet. We also have N2 bus and Modbus standard within the device. In addition, we also have LAN talk built into the device, which is pretty unique. It is a competing protocol, if you will, with BACnet, but typically requires some kind of extra standalone system to support it. With our DDC system, it's a simple plug-in chip. You have immediate LAN talk access. We build units that typically far exceed the lifetime of the use of the building. As we talk to developers, one of the things they really want is they want flexibility, because that building's going to turn over. And today it may be a warehouse, and tomorrow it may be a call center. What you do today is not what you're going to do 3 to 5 years from now. So if you have a system that's modular, that has DDC controls so you can reconfigure it easily, you've got something that fits their need 3 or 5 years down the road when the lease changes. With the IFL, from the very outset, it has such high static capabilities, they won't affect it. You can reconfigure it more easily. This unit didn't get pulled out of thin air. It came from talking to engineers, talking to owners, being in the marketplace and talking to developers. We've had some architects and engineers look at the unit and they're pleasantly surprised by what they see.